So we're going to go over the basics of logarithms, and when you see the expression y equals log base b of x, that's the same, this is equivalent to b to the y equals to x. So essentially, the logarithm is the inverse of the exponential function. So what does that mean? Okay, well, let's do some examples. Let's say I have log base 3 of 9. Okay, so what this says is, this is saying that it's asking you a question. It's saying, okay, 3, which is the base right there, to what power, 3 raised to what power equals this number right here, 9. So 3 raised to what power equals 9? Well, that's 2, right? Okay, so if you wanted to use the definition that we just wrote down here, you would have, so you have log base 3 of 9. So we're going to just do the same problem again. And let's say, since we're trying to find, now I already know it's 2, but let's just say we're starting over. And I want to know what this is. Well, I'm going to set it equal to x, and then this is what I'm looking for. I'm looking for the value of x. And so then what you do is you go, okay, well, I'm going to write it down as an exponential using the definition. So notice that the base of the logarithm is the same as the base of the exponential. So then I have that 3 is going to be the base of my exponential. And then these two, the 9 and the x, are going to be switched places, just like the y and the x and the y and the x do right here. So then 3 to the x is going to equal to 9. So then you go, okay, well, what's the x value that makes this equal to 9? Well, you can either guess that it's 2, or you can write it as 3 to the x equals to 3 squared. And so then you can see that x has to equal to 2. Okay. All right, well, let's do another example. Let's say we have, you want to find log base x of 4 is equal to 2, let's say. Okay, so you can use, again, the same definition. Now, what you can also do is, another way to think about it is that since you want to get rid of the log, well, you want to call somebody that knows how to get rid of logs. And, well, who knows how to get rid of logs? That's right, the lumberjack. The lumberjack comes in and he goes, whack, whack. And then he goes, hey, you switch places. So then you would have x, which is the base, to the 2 is equal to 4. So then you solve for x and you get x is equal to 2. Okay, so the lumberjack knows a lot of things. He knows how to chop down logs. So let's do another one. Let's see if the lumberjack can help us with log base 1/4 of, I don't know, how about 16. So since we don't know what that is, we're going to set it equal to x, and then we go, lumberjack, come on over, knock down the log for me, whack, whack. So then you get that the base is going to be the same, 1/4, and then these two trade places. So you have 1/4 to the x equals to 16. Okay. Now here it's a little trickier because you've got to do a little bit more work here, but we can do this with the laws of exponents. Notice how, I mean, basically what you're trying to do is you're trying to get the bases to be the same. So see how I have 1/4 here? Well, the first thing I can do is I can, using the laws of exponents, bring this up as 4 to the -1. And then all of this is raised to the x, and this is equal to 16. But since I have a 4 on the left side, might as well change this to, instead of 16, I can write it as 4 to the 2nd power. Kind of similar to what I did over here where the bases are the same. Similar here, I want to make the bases the same. Okay, and then you can use the laws of exponents again. When you have a power raised to another power, you multiply. So 4 to the -x is equal to 4 squared. So that means that x is going to have to equal to -2 when you set the exponents equal to each other. And that's it. Okay, so that's how you evaluate logs. Now, how about we go over the laws of logarithms. So we let's just do a quick recap of the laws of exponents. So we have that x to the a times x to the b equals to x to the a plus b. X to the a over x to the b equals to x to the a minus b. And then x to the a raised to the b equals to x to the a times b. Okay, so the laws of logarithms are similar because logs are essentially exponents. So I'll write down the laws of logarithms over here. So I'm going to have the log of a times b equals to log of a plus log of b. And notice that the multiplication of the inside of the logs breaks up into addition of the logs. So notice that it's very similar to the first law of exponents. Okay, and then you have the log of a over b. This is going to break up into subtraction. Just like this one, this second law of exponents breaks up into subtraction as well. And then we have log of a raised to the c is the same as c log of a. Okay, so let's do some examples of using these laws. Let's say, for example, I want to find, let's say I want to combine into a single logarithm. So let's say I have log base 4 of x minus log base 4 of x plus 3. Well, that's the same as, since I'm subtracting, I can use law number 2, right? Log of a minus log of b is the same as log. Notice how the base is going to stay the same. And then inside, subtracting 2 logs is the same as division inside. So it's going to be log of x over x plus 3. Okay, let's try another one. Let's say you have log base 8 of 16 minus log base 8 of 2. Okay, so, well, I can combine them into one log, into log base 8 of 16. Subtraction combines into division. So this is 16 log base 8 of 16 over 2, which is the same as log base 8 of 8. And then this log base 8 of 8, that's just equal to 1. Okay, now let's do an example of expanding. Let's say you want to expand the log base 3 of 5x over z. Let's say 5x squared over z. Okay, so I'm going to use the laws of logarithms. So the first thing I'm going to do is I'm going to break up the division into log base 3 of 5x squared minus log base 3 of z, right? Just break up the division into a subtraction. And then this is equal to, I can now break up the product here into addition. So there's going to be log base 3 of 5, and then plus log base 3 of x squared, and then minus log base 3 of z. And then I'm almost done. The one last law that I can use is this one to bring the exponent down in front. So this is going to equal to log base 3 of 5 plus 2 log base 3 of x minus log base 3 of z. And that's it.